Okay, let's go back to basics and see something what is really in action and the experience about this journey of the long projects. What we can, what was the lessons learned of this? Okay, some words about myself and my experience. I have worked 35 years in automation, in different parts of automation, as a end user, as a system developer, and also project manager. The first OPC UA implementation we made with process in about 8 years ago, and actually 2011 I made my first presentation here in OPC Day. And then I was working with Valio, for Valio, and actually this is a case study from that one, from process. Also on top of that, we made an Napcon installation, and also there we used the same OPC UA platform for what was discussed earlier. The last projects, 4 projects, it's mainly greenfield projects, so we could use really last technology at that moment when we made and integrated, embedded OPC UA servers and clients. So we didn't use any middleware in these projects. Of course, for the first ones we had to use, because at that moment there were no OPC UA servers in the market embedded for PLC. So we used UA Gateway from automation, and process was implementing these OPC UA clients for MES application and SCADA applications. But now we can really use these basic methods and the services of OPC UA, and so the last one, the case factory, was actually I was an automation project head for that, and also made the design of the architecture and how the systems worked together with OPC UA. And the actual project is a little bit even bigger project. It's a manufacturing assembly line, and there is an integration of machine automation, line controllers, and also MES systems all together. And also there is a central SCADA system involved. Okay, I am helping my customers to manage these kind of multi-vendor projects. They are quite complex, and also helping to design these automation systems so that they will be really robust and work well when we will start the production. Okay. The purpose of this presentation is really to share my experiences of that, and at first I will give some idea which kind of projects they were, and then after that I will explain some pitfalls what we have encountered and how to avoid them. Okay, let's build up a smart factory at first. We have given the value stream, how the value is added for the project, for the owner of company, and of course it is controlled by information flow, what is coming from backwards from customers, and how these are then managed. And how these are then controlling the plant in the value stream. So we started with this greenfield, of course, designing the building, the utilities, and these are very important part of the factory, because if this is not working, then also the automation system doesn't work, and the control of the value stream doesn't work really. Often forgotten that how important are the utilities and how they are controlled. On top of that, if you think the ISA 95 model, we have the PLCs, HMIs, operator panels, local control, and of course, if you have the process, if you have also processing parts, could be that there's also digital control systems involved. And when we make requirements for the vendors, mainly they are then process vendors or what are bringing their own stuff. We made a user requirement specification and defining what is really important that they should be able to work without any interfaces to outside world, so that they can control their own process with the basic automation. On top of that, we built up a central control room where we have process control, recipe management, alarm management, history and work execution level. And this is a view where you can see in one display the whole value flow or material flow inside in the factory. You are not just controlling, because this has also, process control system has their own view for this certain process, but here you have the total view. And of course, then you have to get information from each of these systems, but also for utilities, because it is part of the controlling of the plant. And then we started to integrate these things together. With OPC UA data access, we are usually moving data in horizontal way from like the batch data from in-feed to the next process and so on. Interlogging is a little bit difficult right now. With the DSN, I think it is much better. Mainly interloggings were made with Profinet or FieldBus or really I/O wired. But in some cases we used also OPC UA for interloggings. Not for each. This was a conceptual picture and for user requirement specification. And then these systems should be controlled somehow, and then we had also interface to send from recipe management and work execution level the production order or jobs and control recipes for each partial process. And at beginning, this is really could be also done manually, so that there are no integration right now in the ERP or MES level. You should be also here able to control the plant with let's say semi-automatic. And then, of course, to get a lot of information, there we used also OPC DA, like the production events and messages, machine data, alarms, and process measurements. All of these should come with OPC UA DA, also from utilities, not just from the main processes. And of course, in the same time, they built up, or they had already this supply chain management and ERP system with production planning, and to close the gap between business and the manufacturing, we had some kind of MES systems. Also in this process, they built up a new MES system for this factory. And they had also already some integration between ERP and MES, and of course they are sending the jobs or production orders to the work execution level in that. But then to give back the information, confirmations, we used alarms and conditions. So we collected a lot of information, and each line controller or process controller generates these production events messages to the central SCADA system, and they were put actually in the event archive, and the MES system read this through alarms and conditions interface. So there were all jobs starts and then batch start and ends, material movements, produce consumed materials. And each of them are generating this kind of messages, like process events. Okay, this was the basic concept, and this is something what was the result of that. There are about 20 production lines in this factory, about 50 machine vendors with different PLCs. Of course, we have tried to standardize and harmonize this, but if some machine vendor, big machine vendor is saying that no, they have just Omron, it is not very cheap to change it to Beckhoff or Siemens or something like that. So we had, I think, 3 or 4 different PLC vendors in the system. It's quite good. 25 networks, actually 1 network for each process area, and also managing networks. About 1,000 Ethernet nodes altogether, and about 100 PLCs altogether. For OPC UA part, we got everything green here. You can see little greens are OPC UA servers or clients. This is the machine control part or process automation part from vendor, and they have own OPC UA clients or servers. And this is the line controller part. So we build up these kind of line controllers to catch, to communicate and send the parameters to system, and also collect and gather data from the vendor systems. And all of this information is then collected with OPC UA to SCADA system. And these job production orders or work orders or jobs was sent from MES to recipe management system, and these control receipts are then written down to the line controller. When, for example, we change the product, the line controller automatically write the new parameters to the machine controller. So it was fully automated if you change, for example. And altogether we had some 9 OPC UA clients and about 40 OPC UA DA servers. And 1 OPC historian server, and one what I said already, this alarms and conditions server, which in 1 year ago generated something like 4,000 messages per day. These messages like batch start end, job start end, material movements, and produced consumed messages. Right now, I think it is a little bit more, 4,500 and so on. But it is quite much work with the MES to eat everything. But this is only part. Of course, there are a lot of also other information flowing through OPC UA from vendor systems to SCADA systems, and it is the DA communication. So it is working. It is robust. We don't have any actually problems with OPC UA servers or clients right now. But the way to here was quite hard. and such the examples, I would give some examples what we didn't wait at the beginning. For example, this data integrity. It is not really automatically guaranteed. When you have different vendors, OPC UA client is from different vendor as the server, then it easily happens that we are just writing from HMI like to server, and it happens that sometime it is quite slowly. -1 was the reset value. And you can see that it is quite slowly updating all. And the client has written everything at once. But in server side, you could see that it is updating very, very slowly. And that's why we had to do, in some cases, quite a strict handshake protocol, that the server is really looking that every pin is written before the data integrity was guaranteed. If we take another example, when the another client was able to, yes?
Did you expect that it's not written in random order?
No.
It's not ensured by OPC UA?
No, no. It's not, yeah.
In the companion specs, that's what we typically use methods to do that.
Yeah, and but that's why we didn't have any methods or servers. Yeah, okay. But then we find that there was some clients that also could write structured tags, and then the situation was something else. Actually the same structure written, and you can see it is coming at once. One moment. You can see that. So this client writing structured tags, and it is coming in one shot. So there is not needed any this kind of handshake protocol anymore. But it depends from client. You have to know, is the client able to write this kind of structured tags. And okay. So use structured tags if possible, but of course in future you should use methods for that to avoid this. And then if not, then you have to do this kind of handshaking, -1 everything, and then server is checking that everything is written. Then we also found this, that if the OPC client is asking or requesting data much faster than the OPC UA server can do, the publishing and sampling interval is in the server side, it can be that the communication processor in server side will collapse. And then it is quite randomly also happening that sometimes it works well and sometimes it is summed, really summing. And to understand why this is coming, it was not so easy. But then we found that if you have, for example, 1,000 millisecond publishing interval in server side and use 2,000 or 1,500 millisecond in client side, it works very well. No problems anymore. Just quite simple. And this was also difficult. We tried to use strings in both sides, server and client side, but it was so that the client was Intel processor and the server was based on Motorola processors, and they used different endians. And it was always, it doesn't went through this writing of strings. And okay, we got an update half a year later, so we couldn't wait that. We had to then build up everything with double indicators, and it takes a long time. Test, test, and test. So.
But that was not an OPC UA problem. That was a vendor. That was not an OPC UA problem.
No, it was a actually it was a certified interface. Yeah. Both sides for big automation vendors, and probably certified interfaces. But this happens. I don't know why.
Certification is not foolproof.
No.
Either.
Yeah, and that's why you have to test these kind of things before that. So, recommendation for testing: you should do this testing in advance, already in the when you are starting the selecting the right data types and data integrity. Do it very early. And then in FAT testing, you have to test everything, simulate the material flow, do a test plan for where each interface is listed, from the material flow point of view, and then simulate the material flow, ensure that the data content and integrity is right. Handshake protocols works also in abnormal situations, and test all interfaces, not just some. When this is done, you can go in commissioning and wait that it will work in commissioning. Then you should do the same with real material flow. This is the most important thing, I think so, for implementations. And do comprehensive documentation. You use really do some kind of component diagrams where each interface is written, and also define which protocol is used, what is direction, read, write, client server pops up, or methods, security settings, ports, vendor contact information, and so on. This is very, very important. Draw also data flow diagrams, really between each system. This is standard, but it's not very well made in many projects. This is actually from the project what we made in Valio in 2014. And then, if you use visualization, why not visualize also the interface? This is much easier to read, and you can also generate SMS messages if something is down, for example. You can see it at once, and the system administrators can react very fast if something happens. And this has helped many times. Also in commissioning. Okay, that was my part actually, and with my contact information. Thank you.